All right, so for this first problem, let's go ahead and look to see how we would do it. What would this be called? It touches the edge of the circle. That's inscribed. So the technique that we're using is the arc, which is what they're asking for. That's the question mark. What are they asking for? Is that going to be half, double, or the same? For inscribed, I want you to think as half or double. And then the angle right here is the half one. The arc is the double one. So we are doubling. I'll go ahead and use the calculator. It's always use a calculator to be sure if you're not doing it by hand. 118 times 2. And we get 236. So this is the double idea on that one. Okay. We're just going to keep moving unless there's any questions about what's going on. Remember, we'll try to do this again before the end of class. Next one. We're looking for the angle this time. They give us the arc. So half, double, or the same. In this case, it's the half idea. Half. So half of 98 is, what's that? 43, I think. 49, good thing I checked. 49 is half of the 98. All right, so that's the key. This is inscribed. It's touching the edge of the circle. Half of it is 49. All right, so we have to bounce around a little bit to find these parts. Let's see. We're looking for this angle here. Let's use what they gave us. They gave us that this is 35 degrees. So that means I'm going to have to double it to find that arc. So this arc is going to be 70. All right, let's see. I need this arc here. Anything? Oh, there's that 202. I didn't even see it down there. It's kind of hidden a little bit. So, yeah, I didn't have enough with that. So this right here is 202. That's creating an inscribed angle for T here. So that means this T, and here's the hard one. I remember number 3, a lot of us struggled on it. 202, that's going to be half of that. So that's 202 divided by 2, which is 101. All right, so now I know that I got 35 degrees for one angle plus the 101 for the other angle plus my question mark angle. All of those angles have to add up to be 180 degrees. So we'll go ahead and combine these. So that would be 136 for this one, plus my mystery angle, minus 136, minus 136, and our mystery angle is equal to 44. There we go. All right. So this one you had to bounce around a little bit and make sure you're looking at the entire problem. It wasn't very clear, but 202 on the bottom here. Okay. Which number best represents an inscribed angle? Inscribed, we just talked about this. All right, so this is a central, this is a tangent and a tangent point. This is a chord. This is a radius, diameter, center. Inscribed touches the edge of the circle. What is the measure of ACB? A to C to B. So they want to know this one here. they give us it's off the center. It's off the center. So that means, what's that arc going to be? If the center is 45 angle, then this arc is half, double, or the same. It is the same. Center, central, same. So that's 45. And then this is an inscribed angle. Is this going to be half, double, or the same? Well, inscribed is either half or double. This is the big one compared to here, so it's half of 45, 22.5. Next one. Oh, got a lot going on here. The measure of MN. MN, the arc. This is what they want to know. All right. Looks like we're going to have to bounce around a little bit. Things to make note of. This looks like it goes through the center. So I would call that a diameter. This looks like it goes through the center. So I would call that a diameter. Well, I see a shortcut here. So right here, they give us this arc. This arc is 75. This is off the center, so that is also 75. Now, these diameters are straight lines that cross. Do you remember what it's called, the angles that are across from each other on straight lines? Well, that's called vertical. Vertical angles, that means this 75 and this right here is also 75 because they are across from each other. And then it is central again. That means our question mark arc from M to N is what? 75. All right. Let's see if there's another way to do it. Let's see, 75, 50. And then I think we can calculate with the 180 here. So subtract these two from 180. That would give us this one. And then we can also do the 180 one more time for this last diameter. So going from here to here, after you find that blue arc, would give you this last piece again. So there's a couple different ways to do it. In geometry, it starts to kind of turn into these problems where there might be multiple methods to get to your answer. But the one I just talked about is the one using the inscribed and central, and then vertical just uses vertical idea and central. Next one. So there's some things are unspoken in math. That's this idea right here. It goes through the center. It looks straight. So we would call that a diameter. Okay. So that means this total right here is 180 degrees. Let's see. Then that means this right here and this right here. So this arc would also be 180 degrees, which forms this angle. This is a central angle. That means it's half of 180. So that's a 90 degrees. It's also one of the formulas that a diameter creates a like 90 degree angle, but I think it's easier just to kind of recognize through the fact that it's cutting it in half. All right, so I got 39 plus 90 plus angle R, PRQ, PRQ. So this is the one I'm looking for, angle R. All of those are inside of a triangle. They have to add up to 180 degrees. 39 plus 90 is 129. Minus 129, minus 129. Angle R is equal to, what's that, 51. All right. Make sure you can do these by hand on your own. All right, next one. Which segment is not a radius? Not a radius. Well, LM jumps out at me. There it is. Let's just take a look. CA is a radius. CB is a radius. CD is a radius. Yep. Which segment is a radius? Oh, I thought it was the same problem. All right, which one is a radius this time? LM? Nope. BD? Nope. DC? That looks like it. D to C. ML. ML and LM, these are the same. So they're just being tricky. It doesn't matter which way you go on these. An angle in a circle with vertex on the circle itself. Here's our circle. Vertex means a corner on the circle. What's this called? It's your inscribed again. An angle in a circle with a vertex on the center of the circle. The vertex is the corner, and it's on the center. Center, central, same. The distance around a circle, diameter is the line going from side to side through the center. Radius, from the center to the outside. Area, space on inside. The distance around a circle, the perimeter of a circle, it's called circumference. What best describes segment AB? AB, it's a chord works. I like secant too. Secant is the idea that it's a line that keeps going. So that's a secant line usually. Diameter, nope, not going through the center. Tangent would just nick the side. So the best one would be just plain old chord. Secant usually keeps going on. Find the measure of arc AB. AB is right here. This is called, do you remember the vocabulary for this? Inscribed. Yeah, let me go ahead and go back to that and talk about it. So let's finish this one and I'll go back to the last one. Thank you for the question. So is this going to be half, double, or the same? Inscribed is either half or double. This is the big one compared to the other that they give us. So that's double or 68 double. All right, let's take a look. Had a question. Appreciate that. On the last one, the difference between secant and chord. So how are these different? Secant is a line, which means it goes on forever in both directions, going through a circle. That's your secant, goes through the circle, going on forever. The chord is a segment. It does not go on forever. So it's just a piece of a line that touches the ends of the circle. Segment, it's a piece. That's what we have here. It doesn't go on forever. Secant is that one. Chord is that one. Secant's that one. So it's the idea of the line going on forever. Thank you for the question. Yep. Getting close to the end. Name the tangent line here. Tangent line, it just touches it once. Just touches it once right here. That's the tangent line S. Using the tangent lines, find the value of x. This is like inscribed. If you have a tangent, touches at one spot here, touches at one spot here, it's like it's going to be, notice this one looks bigger. So this angle compared to the other one, so kind of look at this size compared to this size, this one's bigger. So it's going to be the double idea. And this one's kind of one of those tricky ones that we don't see very often. But it's, you have to have two tangent lines, and then that angle it forms is going to be double. Just confirm. Yep. Double the 60 for that angle. And it's, once again, it's the bigger and smaller idea. And that's why I've kind of been practicing with you that, because half or double happens a lot with these circles. And that's mainly what you're going to be tested on. All right. What's the value of the tangent line? We talked about this. This was on your quiz. This is like inscribed again. So that means it's either half or double. Okay. So this angle is what they're asking about for X, the tangent angle, compared to this arc. That's 148. So do you think that's going to be half or double? Which looks bigger, right? Hopefully you recognize the arc looks bigger. So this angle is going to be half of it. So half of the 148. Just confirm. Yep. Takes a little bit of practice, getting used to it. Last problem, same idea. It's like inscribed. So they say this is 60. Find the missing value. Missing value. Ooh. This was like the one that on our quiz. Two ways of doing it. Okay. I'll go ahead and I like to show both. So one way would be to look at this line right here. It's on a line, or that arc right here. So that's on 180 degrees. Has to be a total. That means they're supplementary. So if I subtract the 60 from it, that means 120. So this is 120 here. And then would this one be, like that purple I found, would this arc half, double, or the same? Okay, that's going to be your double idea. Okay, it's like the inscribed. So that means 240. Let's look at the other way of doing it. The other way of doing it would be to see that this angle, that's 60 right there, matches this arc. So that's a double again, which means this is 120 here for that arc. All the way around the circle is 360. So what's left right here on this one would be the 360 minus the 120. So 360 minus 120, guess what? 240 again. All right. So I really recommend, as you try this again, write down the problems, interact with them, think about the vocabulary, and do your best on each one.